Hi guys, I'm back and I want to show you how to enter data into Excel, and then I'll have a couple other videos about how to make the specific graphs that I'm asking you to make for your reports. So let me share my screen so that you can see the Excel spreadsheet that is linked on our website. So first of all, I just want to remind you guys that you're going to have to download Microsoft 365, which is free if you don't have a Microsoft product loaded on your computer already. You can also use Microsoft Excel on any of the library or school computers if you're kind of on campus or near in Plumas County. But if you have a .edu email address, which you all do as FRC students, then you have the ability to download that product for free. So I know Google Sheets can do some similar things to Microsoft Excel, but it just doesn't have as much capability. And if you were actually working in any natural resource field, you would definitely be using Excel to do these things. So I want to give you a little bit of practice. So that's why we're going to do it this way. So the first thing that you'll need to do is click on the link about this Excel spreadsheet, and then you'll actually have to download it. You don't want to just use it in the kind of like view option that it will first come up in. And so I've downloaded the data sheet, and then you'll probably have to hit this button, enable editing first. So just be aware that that's an option that you'll have to do. And then you'll see that along the bottom, there's 3 different what are called tabs or sheets, and they have different sets of info in them. So we'll start off in the first tab or sheet, which is called Field Data for Site 1. And so you can see that there's a little table here where you can enter data about the trees that you have in your 1/10 acre plot. So that's info that you should have collected outside in the field, and maybe you made recordings of the dimensions of your trees in a field notebook, or you printed out the data sheet that looks similar to this that I provided on the website to do that. And it's most likely that you'll have less than 30 trees. If you had 30 trees in a 1/10 acre plot, that would be a really dense stand. But you could have that many. It's possible that you could have more, but very unlikely. In the stands that we've measured on campus, we usually have in the range of like 15 to 25. So there's a column here where you would record species. And so we use like species codes like PIPO for ponderosa pine, which is, remember, the first 2 letters of the genus name and the first 2 letters of the species name, Pinus ponderosa. But you could also make some other kind of notation like ponderosa, something that you will recognize, and then just be consistent about the way that you enter your trees as you go. And so if you were out in the field taking measurements with some sort of string or rope that you're wrapping around the tree, and you were actually measuring the circumference of the tree, and then measuring that rope against like a measuring tape to figure out that, for instance, maybe a tree was, 2 feet and 4 inches in circumference. At this point, you're going to need to convert that into just a number of inches. So 2 feet is 24 inches plus 4 more inches is 28 inches. So at this point, if you were taking measurements in circumference, you would want to actually just enter 28 into this table here. And then I have the table set up where there's little calculations you can see in the box here that are going to convert the number of circumference into a number of diameter, which you divide by pi, or 3.14. And then it also calculates the number of the amount of square feet of basal area that tree contributes to the stand by that equation that we used, where you take the diameter, you square it, and then you multiply it by 0.005454. So all that is built into Excel, which is a really handy thing about using Excel. And I've done that for you, so you don't actually need to do these calculations. But if you just enter the different trees, maybe next you have a white fir, and it was 14 inches. And again, just remember that, make sure you're entering it in inches, not like in feet. And then these calculations will happen for you. So on the other hand, I just want to point out that perhaps you borrowed a diameter tape from me on campus, and you instead were measuring DBH actually on your tree instead of circumference, or you already did these calculations in your head or with a calculator separate from your separate from the spreadsheet. Then if you've done that, you can just skip and you don't need to put anything in the circumference column, and you can just go to the DBH column. And so maybe you have a tree, a ponderosa pine tree that has 8.5 inches DBH. And then you have a white fir, for example, that was 16 inches in DBH. And so in that case, you can just type right over these 0 space holders that you have there. And then you'll notice over on the right here, as I start to enter data, there are some calculations, again, that are built in. If I click on this cell here, I can see that this is taking an average of what of the cells that I have in here. So the first thing that you're going to want to do is take this calculation of average DBH. So when you're done entering all your trees, so ponderosa pine, maybe you had another ponderosa pine, or you could just write ponderosa, that was 12 inches. And then you'll certainly have more than 3 trees, I imagine, but just for time's sake, I'm going to stop there. What you'll want to do to make sure that these calculations are accurate is go through and then delete out all these DBHs that are these 0 placeholders. So you can just go through and use your arrows to click on these different cells. I thought I would be able to just do it all at once. Oh yeah, delete. And then this cell here will be calculating an average of the cells that have values. So this cell is calculating the average of D6 column, which is D6, this number here, down to D35, but Excel ignores cells that have nothing in them. And so it's calculated in an accurate average as long as all these cells where there weren't trees are blank. If you had left the zeros in, it would calculate the average based on a bunch of trees that had no size. So the number would have been wrong. So once you get all your trees in, you can delete all the rest of the zeros, and then these numbers should come out accurately. Here, it's calculating the average DBH. It's calculating adding up all the basal area from all the trees here, and then it's multiplying it by 10. Since your plot is a 1/10 acre plot, remember we have to multiply by 10 to imagine how much would be going on a whole acre, since there's 10 1/10 acre plots and a whole acre. And then this cell here, you're actually going to have to count up. There are ways to do this on Excel, but it's kind of complicated, and you should have a pretty easy time doing it. So basically, you just count how many trees you entered. So in this case, it was 3 trees. And then once you do that, it's going to multiply it by 10 in the cell below to determine that if you have 3 trees on your 1/10 acre plot and you imagine the whole acre is similar, then you would have 10 times that, 30 trees on the whole plot. So this is what you're going to do. These are the calculations that you're going to make here. And then this is data that you would put in your report about kind of the state of the stand. And then you would go to field site 2 and then enter that for the second plot that you collected. Do the same thing for the second plot. Okay, so I'm gonna stop there, and then I'm gonna record a separate video about what you'll do with these next 2 sheets or tabs, which is where you're actually gonna use this data here to calculate or to construct some graphs. Okay.